Okay. All right. So today we're going to talk about removing discontinuities. I really like these problems. Some of them are a little tricky, but I think they are like fun puzzles to figure out. So, and we're not going to really see any applications per se here today. But I have given, we don't have a lot of time after the AP exam, so we probably won't do the roller coaster project that I've done before where we've got to make everything continuous and differentiable. But when we do that, you do have to use sort of some of this to make those equations. I don't think we're going to have time for it because we don't have a lot of days after the exam. And I have before taken classes to Carowinds, but since we've done the early start, it has not worked. Plus, I think Miss Burton made a rule saying we can't go on field trips like the last few weeks of class, because a lot of people were taking field trips the last few weeks of class, and so then kids were all missing like the last review and everything for their classes that mattered more. For you guys, it would not probably matter as much because a lot of you guys probably have Surrey classes or electives or online stuff that is probably also going to be done about the same time as AP. But I know Miss Martin was saying she would be teaching Math 1 or 3 that both have EOCs and just have 7 kids going on a field trip. It seemed like every time she turned around. So I don't think that we'll probably get to go to Carowinds. It doesn't work with our schedule very good. But we did used to get to do it once upon a time. That doesn't have to go. Yeah. Wonder if yeah, so yeah. I know last year I didn't even ask for an exception because Carowinds is only open Thursdays and Fridays, or sometimes just that early in the season. And when I looked at the calendar, there was it was senior play or it was senior stuff every day we could have possibly gone. So I didn't even ask last year because it wouldn't work. But we'll see. All right. Okay. So for this, it says f is continuous for all real numbers. What is the value of k? So if f is continuous for all real numbers, that means probably that this rational function has a hole, and that this, which is just going to be a dot that fills in that hole, must fill in that hole, right? So if we're wanting to figure out where that hole is at, here we need to do the limit as x approaches -2, because -2 is the place where we're going to have a discontinuity on that graph. So if we do the limit as x approaches -2 of x squared minus 4 over x plus 2, we would need to factor the top. And so that factors into x plus 2, x minus 2, and the bottom is still x plus 2. And so our x plus 2's cancel. And so we would plug in the -2, -2 minus 2, we would get -4. So whenever you find this limit, it's telling us that as we approach -2 here on our graph, our y coordinate approaches, wrong direction, -4. Right here. So I think this looks linear. In fact, I think it would look like this. It's the x minus 2 that's left right there. So what we have is we've got a hole in that graph, and that y-coordinate right there would be -4. It approaches -4, but it doesn't equal -4 because it gives you 0 in the denominator. So what we need in this particular case is this is just going to be one single point, and its coordinates are going to be -2 whatever k is. So what we need is we need it to fill in this hole right here. So that means that k in this case is going to equal that -4. If k equals -4, then that red dot right there will fill in the hole that you would have in your graph, and the graph would be continuous. Okay, questions there? Okay. So for this one, this equation applies for x is greater than or equal to -20 and x does not equal -4. Okay, so why did they include the greater than or equal to -20? What if I tried to plug in -30? Negative underneath the square root, right? So this part is like your domain because of that. X has to be greater than or equal to -20 or you'll get an imaginary number. Why did they say x cannot equal -4? 0 in the denominator, right? So what I need to see here is if I have a hole, or if I have a limit at x approaches -4. They're telling us g is continuous for all x greater than -20. That x having to be greater than the -20, that is non-removable. So you wouldn't be able to like just fill that in with the hole. But they're telling us we just want x is greater than -20 to be where we're continuous. So that -4 is the number that's the issue right now. So we're going to do the limit as x approaches -4 of the square root of x plus 20 minus 4 over x plus 4. And if we try to do that right now, we will get 0 over 0. So we are going to have to do something to solve this. What do you guys think? Multiply by the conjugate. So we're going to multiply by the square root of x plus 20 minus 4. And on the bottom, make sure you put this in parentheses. And then you're doing square root of x plus 20 minus 4 here as well. Oh, sorry, it is. Thank you. Okay. All right, so square root of x plus 20 times square root of x plus 20 is x plus 20. And then I'm not even going to write this because the reason we chose the conjugate is because here on the outside we get +4 square root of x plus 20. On the inside we got -4 square root of x plus 20. Those are always going to cancel out. That's the reason you choose the conjugate, right? But the last term, -4 times +4, is going to give us a -16 right there. And don't try to multiply the bottom together because you want something to cancel. So that's what you're hoping for. You don't really want to factor. You don't really want to multiply this together because then you just have to factor it back out. And it would not be easy factor. Oh, I've been lazy. What did I forget? My limit notation really should still be here. Okay. This is going to be x plus 4. I'm still being lazy. Limit as x approaches -4 of x plus 4 over x plus 4 times square root of x plus 20 plus 4. And so the x plus 4's can cancel. One thing I had a few of you mess up on the quiz. The top, in the top, yeah, plus 20 minus 16. Yeah. Now, one thing I had several of you mess up on the quiz is that you just like started plugging in like this was in the numerator. Is this stuff in the numerator? It is not. So what do we have to put in the numerator to hold the place? A 1. A 1 goes in the numerator. So we're doing the limit as x approaches negative 4 of 1 over the square root of x plus 20 plus 4. So that is going to be 1 over square root of negative 4 plus 20 plus 4. It's going to be square root of 16, which is 4 plus 4, and we will get 1/8. And so if you have a limit that exists, it's telling you you've got a hole in your graph right there, and the y-coordinate is 1/8. So in this case, for k, you want k to equal 1/8. Okay, questions there? Okay. This one is quite a bit different because my piecewise function is a lot different here. The last two piecewise functions that we did had like, here's our equation that we use almost everywhere, and here's the one single dot to fill in our hole, right? This piecewise function is not, you don't have like a single dot sort of scenario. You've got like a piece over here and another piece over here, and what you want to do is choose the right value so that they meet, so that they have the same limit from the left and from the right. So the way that you do these is going to be quite a bit different. First of all, for this problem, they're only asking us about negative 1. So we really only care about what's happening right there at negative 1. So we're really not using that bottom equation at all for what they are asking us to do here. If they asked us to make it continuous everywhere, we'd have to think about that bottom equation. But they're only asking us about the single point at x equals negative 1. So if I do the limit as x approaches negative 1 from the left of f of x, which function should I use? Negative x. So it's going to be the limit as x approaches negative 1 from the left of negative x. And if I plug that in, I've got negative 1, and I will get 1. So on our graph, what's happening here at negative 1 is that we've got, this line that's doing something like this. It's stopping at negative 1. We've got open circle with it because it's not got a or equal to with it. Then we need to think about the limit as x approaches negative 1 from the right. But this is going to be a little bit different because we got an extra letter here, right? So what we're going to have to do is it'll look like this. We'll do limit as x approaches 1 from the right of f of x, which is going to be the limit as x, approaches negative 1 from the right of negative x squared plus x plus c. We're going to plug in negative 1, but only for the x, which means what's going to be left in our answer that's not normally there? The c is going to be left in our answer. So we'll have negative 1 squared plus negative 1 plus c, which is going to be negative 1 plus negative 1 plus c. So we get negative 2 plus c. that's the answer to that piece. That's our limit from the right. But the question is asking us to find C if this is continuous at x equals -1. Okay? So we can set them equal to each other, and Joshua is right, it's going to be 3. Because if we've got -2 plus c, we need the limit from the left to equal the limit from the right, which is just 1, and we would just add that 2 to both sides, and c would equal 3 for that. Questions? Okay. This one is going to be calculator active, so grab your calculators. Wonder if this Swisher's still doing it. I know that Hunter said last year that she didn't really do it because they don't really use the calculators all that much. They use Desmos most of the time. So yeah.
Yeah.
I mean, I get scared too.
Yeah.
I did not want to get it.
Yeah.
I was terrified.
Yeah. Okay. So in this case, we need to do pretty much the same thing. But if we do, in this case, the limit, 3 is our issue that would make this not continuous, because it tells us you're continuous for all real numbers. E is an exponential; it's continuous everywhere. 2x plus a is also it's a line; it's also continuous everywhere. So the only issue is that we need our exponential and our line to meet up at x equals 3, right? So we're going to do the limit as x approaches 3 from the left of f of x. Which, from the left, which equation do we use? The first one. So we're using e to the a x. What are we going to get when we plug in our 3? E to the a times 3. You're probably going to see it written this way, e to the 3a instead. And can we do anything else with that? Not with that a right there, okay? And then we've got the limit as x approaches 3 from the right of f of x. And we're going to use the bottom equation for that one. So 2x plus a. We're just going to plug our 3 in only for the x, not for the a. So we got 2 times 3 plus a, which is 6 plus a. So this is harder than the other problem because we have got both of our expressions have a in them, right? And if we set them equal to each other, because that's what we need to do, we need these two things to equal each other, we will get e to the 3a equals 6 plus a. And if there is a way to solve that by hand, I am not aware of it. You could like natural log both sides, but the problem with that is if you go down that road, then you get 3a on this side, but over here you got natural log of 6 plus a. Well then, if you're trying to get rid of the natural log, you're going to have to use e to the power, and it's going to put the other side back in the power. So I don't think I know a way to solve it by hand. So that means we're going to need to use the calculator for it. So you have two options if you want to solve something on the calculator. The first way is to use the exceptional power of the TI-89 calculator. So the solve feature on the TI-89. Okay, so if we go to F2, I'm going to choose, oh, why is it not working? Refresh, maybe it'll work. Okay, made it look different, but maybe it'll work this time. Okay, F2, which is, it's got that little arrow and it's algebra. And then we want to choose number 1, solve. Like that's not an 89. Definitely not that. You do have to be on the main home screen, or it will tell you something different. Yeah. If you're not on the home screen, it might, if you're on the graph screen or a different screen, it might have your F2 might be different for that. All right, so the words down here, solve, are going to show up. All right, here's what you have to type in. You will type in your equation, and then you'll type a comma, and then you'll type the variable that you want to solve for. In this case, it is an A, or if you'd rather use X's, you can, and then you're going to close the parentheses. So if you want to use an A, I'm just going to use an A here. You just hit the alpha button, which is right beside of your green button, and the equal sign has the little A above it. So you will say E to the is right above the X, so green button X, E to the 3A. Oops, that's not an A. Okay, alpha equal sign. Make sure you close that parentheses. You're going to hit the equal sign, not the enter button, but the equal sign that's over here. And then you'll do 6 plus A, so alpha A. If you'd rather type this in with X's, you can. It's a little easier to type in, but and so you've typed in your equation. You're going to hit. You have to tell it though what variable it's solved for. It can actually solve equations for variables in terms of other variables. So you could maybe have 2 variables and it'll solve it for you. So you'll put comma, alpha A, close your parentheses. So it'll look like that. You'll hit enter. It will for a minute. Notice that mine, underneath it says questionable accuracy, and whenever it was calculating, it said warning, more solutions may exist. So this is not, the calculator is estimating. Sometimes it will miss things. I'm going to show you a second way that you can use for that. The comma is right above the 9. When you're learning to use these calculators, it's frustrating learning where everything's at. You're like Joshua's like my dad was whenever he learned how to use a computer.
This is what he looks like trying to use his phone.
Yes, if you hit the arrows, it'll go back over to wherever you want to be. It works more like a cursor, like when you're typing for this, and then you got that button beside your clear button is your erase. How much different?
Like it says A equals, like it says A equals 4, A equals 4, A equals, and then mine says like A to the third times A minus A.
That's what mine says.
Let me look at those two.